Hey everybody, Mr. Bowman here. This video is all about 2.7 calculus and hopefully it really helps you out with your end of year exam revision. And in particular, we're focusing on all the achieved questions from the 2019 exam. So from the website link, we're on question number 14 and we've been given a function. It's over here. And we've been asked to find the gradient when x is equal to 2. So let's jot down question number 14. I always start these questions by rewriting out my original function. I find when I am rewriting it, I tend not to make those silly math errors, which I'm otherwise prone to do. So that's going to be squared minus 17. The question is all about the gradient. So we have the function. Our job is to differentiate. That way we can get to the gradient function. So my notation, f dash x, that tells me it's the gradient function. That's going to be equal to 4x cubed plus 6x, and then that 17 is just going to go away. So I've got my new gradient function. I've now been told to focus specifically at x equals to 2. What's going on? So f dash 2, notice the x has gone away and the 2's gone in for my notation. That's going to be equal to, and I'm going to substitute out both of those x's and I'm going to put 2 in its place. So it's going to be 4 times 2 cubed, then I'm going to go plus 6 times 2. So I guess BEDMAS, we're going to do the exponents first. 2 cubed is 8. 8 times 4 is 32. So it's going to be 32 plus the 12 that I've got over there at the end. And that combined is going to get me to 44. So what that means is when x is equal to 2, my function is going to have a gradient of 44. So that's quite a steep positive incline at that particular point. Okay, we are now on to question number 15 from the website. So question 15, a function px has a derived function of p dash x. If px passes through this particular point, so that point's really nice. That gives us an x and a y, which we might need to use later on. We've been asked to find the original function of px. So as always, just like I did for the first question, let's start off with by jotting down my function. So p dash x is going to be equal to 5 minus 8x cubed. So we've been asked to find px. So just a reminder, so px is always going to be equal to the integral of p dash x in terms of x. So basically, I'm just going to have to integrate my p dash x function, and that will get me most of px. And I'll explain why I said most of it shortly. So let's integrate. So 5 is just going to become 5x when I integrate, so I add that x back on. 8x cubed is going to be a bit trickier, so we're going to write it down 8x cubed as it is, and then we're going to go plus 1 to the power, and then we're going to divide it by whatever the power is. And then we've got plus c. And I'm now going to simplify that middle part because that looks a bit messy. So we're going to have 5x minus, so we've got 8 divided by 4, so that's just going to become 2. So that's 2x to the power of 4 plus c. So this c here is the annoying part. We haven't got the function yet. We've got most of the function, but we need to find out what that constant was. And that's where that x and y is going to come in handy. So we know from that coordinate that when x is equal to 2, y is equal to negative 25. So I'm going to substitute both of those into my function over here. So I know that this function here, all of it combined, is going to be equal to negative 25. So I'm going to write negative 25, and that's going to be equal to 5 times 2. Noticing 5x, I'm taking away the x, I'm putting in the 2. And I'm going to do the same here again. It's going to become 2 times 2 to the power of 4. And then we're going to have plus c. So this equation we're left with now, there's only one letter left, which is the c. I'm going to go ahead and use algebra to try to figure out what that is. So let's start simplifying. So we're going to have negative 25, and that's going to be equal to 5 times 2, which is 10. And we're going to minus 2 to the power of 4. So that's going to become 2, 4, 8, 16. And we're going to times that by 2. So that's going to become 32. So it's going to be minus 32 plus c. Rearranging all of this, so we're going to have negative 25 is going to be equal to negative 22 plus c. I'm going to add 22 to both sides to cancel out that, which means C is going to be equal to -3. So I'm now going to put that back into my original equation that I had before, and that will give me the function px. So therefore, px is going to be equal to 5x minus 2x to the power 4, and then we're going to subtract 3 from that. Okay, we've got the final question number 16, which is from the website, and it revolves around a remote control car. So we've got a remote controlled car. It's moving back and forth on a straight track. The distance is done by this equation here. So that looks like a displacement formula, which maybe makes me think kinematics. And we've been asked to find the initial speed. So I guess the point of the question, the initial speed, that means we're looking to figure out velocity and initial. So velocity, in particular when t is equal to 0 is when we're trying to find that out. And the nice thing about this is because we've been given the displacement, so the displacement in terms of time, can't read that because of the yellow, but that was 6t minus t squared. If we differentiate the displacement, we're going to get to the velocity. So the velocity in terms of time is going to be equal to 6 minus 2t. And as noted before, initial speed means t is equal to 0. So our velocity when t is equal to 0 is going to be 6 minus 2 times 0, which is just going to be 6. And don't forget our units. So this is meters per second. You might also write meters per second minus 1 as well. Both of those are all good for your units. So that question there, pretty quick to go through. The maths itself was nice and easy, but if you can get into the kinematics part of it initially. So that wraps up all of these questions. I really hope it benefits you in your exams. Thanks so much for watching. Make sure you check out the other Achieve Merit Excellence videos for exams. Thanks again.